Hello everyone, this is Shihong Wu from Chaoyang University of Technology. I will present CYUT Team Chinese Grammatical Error Diagnosis System report in NLPTEA 2020 CGED shared task. This is our outline. Learning Chinese is very popular for foreigners, but it is difficult for them to write correctly sentences. Grammatical error detection is a big challenge for the Chinese learners as a second language. The NLPTEA workshop provides a serious Chinese grammar error detection shared task to promote the research on grammar error diagnosis. The organizers ask professional teachers to label the errors in learners' sentences. There are 4 types of labels in the sentences: and redundant, selection, disorder, and missing. This year, we submitted 2 rounds for this shared task. In our round 1, we used BERT as the first level of our identification system. We fine-tuned the BERT model with the Lang, Ba, or language aid corpus, and all the data from NLPTEA since 2016 to 2020, so that the model can be used to predict correct and incorrect sentences, and reproducing the wrong sentences. The error types are determined by CRF. In our second round, we used the basic CRF and the dataset mentioned above to complete the training. We mainly focus on minimizing the false alarm on error detection and hope that less errors judged by the model will not cause learners to feel frustration. This task is divided into 2 stages of training. In the beginning, the BERT will be fine-tuned using the information provided by Len 8 and NLPTEA. After that, 50,000 randomly selected from the above-mentioned dataset were used as CRF training data. This is our system architecture. We use sentences from these 2 training datasets to fine-tune the BERT classification model and use BERT as the classifier to judge or to predict whether a sentence is correct or an error sentence. And in our second round is the CRF-only system. In this case, we use CRF as the classifier to identify the error type and the error position. During the preparation of our system, the preprocessing system is working like this. The original sentence and the rewritten system will pass the JBA subsystem that will do the segmentation and the POS tagging. And after we make the prediction, we use edge distance to make sure the error type and the error position. This is the result of our system. We mainly focus on the false positive rate. The lower the better. So our first run get this 0.0163 false positive rate. This is the lowest false positive rate in this year. The average runs is 0.3920. And our round one also give good precision at the detection level, which reached 0.98. This is among the highest ones. But our system give back on recall. Our recall is not very high. So this result of F1 measure is also not very high. Here we show that some sentences that will cause our system fail. The main reason is our system focuses on short sentences. So these 5 sentences are quite long and our system could not deal with them. And we find that there are 460 such kind of long sentences in the test set. And we also find that most of the redundant type of error is about the and the. And this status shows that many errors are concentrated on certain high-frequent characters. In the future, we might focus on the high-frequent errors. Conclusion. The result shows that our round 1 achieved the highest precision rate with the lowest false positive rate on error detection. Our system can point out errors with a very high confidence, but our system could not point out the correct position. That's the future work. In the future, we will combine the method of BERT and GPT-2 to improve sentences that our current system cannot detect effectively about the correction level. We also hope that we can filter out the best alternative words through GPT-2's sentence rewriting method. That's all. Thank you for your listening.